Hello, everyone. Let's have a look at this question from Regional Maths Olympiad question 2013, paper 1. So what we have here is two functions, cubic functions, f of x and g of x, where a, b, c are integers. Integer means positive or negative numbers, whole numbers, with c not being equal to 0. Suppose that the following condition hold. Okay, so the conditions are f of 1 equals 0, and then the roots of g of x are the squares of the roots of f of x. And we want to find the value of a to the power of 2013 plus b to the power of 2013 plus c to the power of 2013. Right, since a, b, c are integers, we should be trying to find what a, b, c are. Okay, so if we find a, b, c values, and we can sub into there, and we can get the answer. Now, we have a, b, c inside both the functions in different places, right? B is in front of x here, and b is the coefficient of x squared there, and the rest are again. A is in front, a is the coefficient of x squared, a is a constant there, coefficient of x to the power of 0. Now, what we should be aiming to be able to answer this question, we should write a in terms of c, b in terms of c, right? I don't know, maybe, yeah. So I shouldn't write a equals c. A in terms of c, a in terms of c, b in terms of c, and c will be just c. And if you figure out what the value of c is, then we can sub it in these two, get the values for a and b. Or you could try and write a in terms of b, b is gonna be b, you can find what that is if you can, b is b, and then c is gonna be in terms of c, in terms of b. We're writing all in terms of b. Or vice versa, you can write every other constant in terms of b except a. Okay, but what I'm gonna do, I'm gonna be writing everything, every constant in terms of c except the constant c. So first of all, what do we have? We have the first condition, f of 1 equals 0. What does that imply? From factor theorem, you should remember that this means 1 is a root of f of x. Now, this is a cubic function, f of x is a cubic function. So that means we will have 3 brackets when we are solving them. Okay, so one is x minus 1, this root. The other one will be x minus, let's call it p, and then x minus q, let's call it q. Okay, right, since condition 2 tells us that the roots of g of x are the squares of the roots of f of x, since f of x has a root 1, therefore 1 squared, for g of x we will have 1 squared, which is 1, so therefore 1 is also root of g of x, which means g of 1 equals 0, right? And the root p for in f of x was p, but in q it will be p squared, right? So we get p squared, 1 root, and also this q in g of x, it will be q squared. So we can write g of x in this way as well. So x minus 1, x minus p squared, x minus q squared. Okay, now I'm just gonna write everything in order. So what did we have? F of x, I'm gonna write the whole thing. F of x equals what was that? X cubed plus ax squared plus bx plus c, and I just wrote that as x minus 1, x minus p, x minus q. And the g of f(x), I wrote it as it was g of x was given as x cubed plus bx squared plus cx plus a. And that's equal to x minus 1, we said, x minus p squared, and then x minus q squared, right? Okay. And then the next stage will be, well, I can find, if I expand everything you may need, you may not want to expand everything, but let's just try and find what the constant's gonna give us. Okay, let's do that constant. So how do I get just the constant term? I just multiply all these three, right? Similarly here. Okay, let's see what we get. So we get from here c is equal to minus 1 times minus p times minus q. Therefore you get c equals minus pq, hence we can write pq as minus c. Okay, and on the other hand, the constant here is going to be minus 1 times minus p squared times minus q squared, which is a equals minus p squared times q squared. Therefore p squared q squared equals minus a. Okay, I'm hoping this is good so far. Right, what did we have so far? We had pq equals minus c from here, and then from here we had p squared q squared equals minus a. Well, we can combine these two to get what a is in terms of c. So if we square that, this is p squared q squared equals c squared, right? I'm squaring everything by 2. I'm squaring both sides by both sides, and then since this is also p squared, this is also p squared, that means minus a is equal to c squared. Therefore a is minus c squared, right? So if you find the value of c, let's say 2 or minus 1 or 1, you sub it in, we get the value of a. Now what's left? We have to find the value of b, right? So we have written a in terms of c, right, which is going to help us to find that number, and c is just going to be in terms of c, so that's going to help us to find this number, and we should try and work with b now. So how do we work with b? Again, we should be copying everything down. Let me just do that. Okay, I will erase some of them. Okay, so copy, paste. Right, let's erase what we don't need. Okay, so that's what we had. Okay, let's get rid of that. Now this time to find b, just check where b is. B is the coefficient of x. So that means bx is equal to, now coefficient of x means I just need to do x in this bracket and the other two constants in the other brackets times together. So if I do x times minus p times minus q, I'm going to be getting pq x, and then again do the same thing, x in this bracket, constant in the other two, which will give us plus px. Again do the same, let's change the color, and do the same with this x, and then this constant, and then this constant. That's gonna give you, oh, that should have given you q. Okay, and then the blue lines I've underlined will give you plus p x. Okay, minus p times minus 1 is plus p times the x. x. Okay. Right. Well, we can cancel the b's out, the x's out, which will give us, therefore, b is equal to pq plus q plus p. Okay, that's not in terms of c, as you can see, but let's carry on, find what this b is going to be equal to in this case, in the g of x. So again, bx squared, just expand the, get x squares. So x times the constant, so that will give you minus q squared x times the constant times this x. Maybe I should use different color or highlight here. X times constant times x, so that's minus p squared x. Then one more, this x times constant, this constant times this constant. Which x did we do? Second, let's get rid of. Okay, so we did this x and this x. We did this 2x. We haven't done these 2 x's, right? We have to do these 2 x's times with minus 1, which is minus 1 x squared. Oh, there's an x squared. X squares will cancel. Okay, so b is equal to minus q squared minus p squared minus 1. You can square the minus 1 out. Okay, so minus b is equal to q squared plus p squared plus 1. Okay, now these b's we have found are not in terms of c's, right? So how do we make it in terms of c? So far, and previously we did find the constant a in here using the g of x function, right? And it was just timesing the constants together. But we could also find the a, constant a, using the f of x function. Okay, so let's do that here. Let me just copy paste something here. Just copy paste that. Copy, paste. Okay, let's erase that. So erase this. Let's do that. Okay, so let's put those back. Okay, so the a is here, this time is in front of the x squared. So how do we get x squared? This times that times that, so minus q x squared. Or we can do this x times that constant, which is minus px squared. Or we can do this x times this constant, which is minus 1x squared. So comparing with the left hand side, the x squares cancel. So that means a equals minus q minus p minus 1. Okay, I can factorize the minus 1 outside. P plus q plus 1. So this is minus a equals p plus q plus 1. Okay. Right. The b's were in terms of q squared and p squared here, and then we had p times q and then plus q in here. Yeah, so remember this. So what we need to do is we should be able to get q squared p squared by doing something, right? So the only way we can get that is if we square the whole thing. So minus a squared equals p plus q plus 1 squared. What do we get? We get a to the 4, a squared, not to the 4, plus a squared equals, I'm going to write this a little bit differently. Okay, plus 1 squared, and then expand that. So this is p plus q squared plus 1 squared, expanding quadratic equation, right? I'm just applying that. So a squared plus b squared plus 2ab. So applying that here. And then that will be another plus 2 times p plus q plus 1. Expanding it, this one again, p squared plus q squared plus 1. So we need to do the 2 times pq, bring that 1, plus 2p plus 2q when you expand that. And then we can factorize with the ones with the 2. So what do we get? We get p squared plus q squared plus 1 plus 2 times pq plus p plus q, right? But on the top, we did find that pq plus q plus p is 1, is b. So this is b. Okay, so this is equal to b. And we also found, I forgot to write 1 here. There's a 1 here. And we also found that q squared plus p squared plus 1 is equal to minus b. So this is this is minus b. Overall, we have minus b plus 2b, therefore is equal to b. What is b? Well, it's a squared equals b, right? But we found a squared in terms of c, and we're going to let c be c, but what is b in terms of c, right? That's what we want to find. Well, we know what a squared in terms of c is, right? A was minus c squared, actually. So a was minus c squared from the top. So minus c squared all squared equals b. Therefore, we get b equals c to the 4. Okay. So far, okay. So far, we have a equals minus c squared, which we found out. B is c to the 4, and c is gonna be c. Okay. But if we know what c is, then we can sub it into a and b and figure out what our final desired answer going to be, right? So first of all, once again, returning back to the condition 1, which was f of 1 equals 0. What that means, this is x equals 1, and if we sub that into our f of x, which was x squared plus ax squared plus bx plus c, we're going to end up with 1 squared plus a 1 squared plus b times 1 plus, and that's a cube, plus c equals 0. And we get 1 plus a plus b plus c equals 0. Okay. Okay. And then we can factorize that. I'll leave, well, we can't factorize it yet. We need to sub in the values of a, b, and c. So a was minus c squared, b was plus c to the 4, and c is c. Let's write it a bit nicely. Okay, so 1 plus c minus c squared plus c to the 4. It's the same thing as that. Factorizing. So if we factorize, we will get 1 plus c, and then 1 minus c squared plus c to the 3. Now, we are told c cannot be 0, and c is an integer, and if you solve that, I'll let you solve that yourself, that doesn't give you an integer solution. So, not integer solution. But this, at this bracket c plus 1 equals 0, c equals minus 1, which is an integer. So this one satisfies what we are looking for. Okay, therefore we can sub it into our equations for a, b, and c. Okay, let's bring that here. Okay, so in this case, a is gonna be minus 1 squared, which is minus 1. B is minus 1 to the power of 4, which is 1. C is c, which is minus 1. Okay, so a is minus 1, b is 1, c is minus 1. And we wanted to find a to the power of 2013 plus b to the power of 2013 plus c to the power of 2013. Okay, what does that give us? Well, if we sub in a, which is minus 1 to the power of 2013, that is minus 1, is an odd power, plus b to the power of 2013, which will give you plus 1. Okay, and then plus c, which is minus 1 to the power of 2013, which is also minus 1. If you put all of them together, you'll end up with minus 1. Okay, so the answer that we required is going to be 1. Okay, that was long. I hope you've enjoyed this session, and I hope to see you with other maths problems. Thank you very much for watching. See you next time.